Hello, everybody. Mr. Klein here, and I thought it would be helpful for us to do one of these examples together. And the example we're going to do is number 2. So let's see what this says: salt and systolic blood pressure. So here's an equation. It says this uses an individual's average daily salt intake to predict his or her systolic blood pressure. And if you look right here, this graph. Each one of these points is an individual where we measured their salt intake and their systolic blood pressure. And you can see that there's a positive trend. So as the salt intake increases, so does blood pressure. All right. So with that in mind, let's answer some of these questions. Hey, something that might be helpful to you as you're answering these questions is right here, this formula sheet, which the last page of it has all kinds of regression stuff, like what the y hat and the y and the a and the b and the residual, the correlation, what all of those things mean. All right. So with that in mind, without further ado, let's begin. So I've written down my equation here. I'm going to note that salt is our x value, and hat SBP means the predicted systolic blood pressure. And question number, or letter A, says GN number 1 consumes an average of 3,990 milligrams of salt per day. What is his predicted systolic blood pressure? Right. So if you want to predict systolic blood pressure using salt, you got to plug salt in right here. So I'm going to take his equation. I'm going to do this with it. And multiply by how much salt he eats. Then I'm going to grab the calculator and let's see what we get. So we would predict his blood pressure to be 128.399. Hey, do me a favor, include units on these. So this will be millimeters of mercury. B says this: when GN number 1, so we're talking about the same individual here, goes to the doctor, he finds that his actual systolic blood pressure is 132 millimeters of mercury. So we want to calculate his residual. All right, well, let's see. We already have the y hat. That was 128.399. And we were just told that his y is 132. Recall that a residual is the observed minus the predicted. So 132 minus 128.399 is going to give us we'll just call that 3.6 millimeters of mercury. Same units as Y has. Now C asks us to explain in real world terms what this means. So the first thing we want to note is that it is positive. Because it's positive, what that's telling us is that his actual blood pressure is this much higher than we would expect based on his salt intake. So GN number 1's systolic blood pressure, his Y value, is 3.6 millimeters of mercury higher than we would predict from his salt intake. Cool. Let's take a look at D. D is about GN number 2. So let's see. Here's what it says. It says GN number 2, who consumes 3,880 milligrams of salt per day, a little less than his brother, goes to the doctor with his brother. the doctor reports that his systolic blood pressure is 119 milligrams or millimeters of mercury. Calculate his residual. All right, so we were already given this. We were given GN number 2's observed, and it is 119 millimeters of mercury. Now, the other thing we were given is his X value. His X is 3,880. And the way we're going to use that is this. We're going to plug it into the old equation. Right here, in order to find his predicted systolic blood pressure. So that would be you know what I'm going to do? I'm just going to copy that. 88. And there we have it. 125.649. Now, a common mistake I see students making at this point is we figure out, I got to compare these two numbers. And this one right here is, what is that? 6.6 units higher. So we say the residual is 6.6. Now, the issue with that is this. Remember that the residual is the actual minus the predicted. So while we are finding the difference between these two numbers, notice that since we're subtracting the bigger number, the answer is going to be negative. So in this case, it'll be about 6.649 millimeters of mercury. E asks us to interpret what that means. Well, think about this for a second. What would it mean for the residual to be negative? Doesn't that mean that his actual blood pressure is lower than we expect? So because of the negative, we're going to say that GN number 2's systolic blood pressure is 6.649 millimeters of mercury lower than we would predict. And you always want to say how we would predict it, because there's lots of ways to predict systolic blood pressure, isn't there? I mean, there's SALT, but there's also, your race, your age, your alcohol consumption, the amount of potassium you consume, how often you exercise. There's lots of different ways to predict this. We are predicting it from SALT intake. Cool. All right. F asks us to describe the slope. Now, the first thing I want you to do is write down that we know the slope is the change in y over change in x. And the slope was given to us as 0.025. Remember that slope is always the number that multiplies the x value. So I'm going to start by writing that over a 1, and then I'm going to put units on it. The units of y, which, by the way, this is predicted, are millimeters of mercury. The units of x are milligrams of salt. So we would interpret this as the predicted systolic blood pressure goes up by this much for each additional milligram of salt. Now, this may seem like a small number, but let's keep in mind that 1 milligram of salt is like microscopic. If this sentence is tricky for you, if it's confusing, I want to remind you that you have this formula sheet, same formula sheet we've been using all year, And under slope, I actually wrote the sentence out. The value of y is predicted to increase or decrease by whatever the slope is for each additional unit of x. So you can always use that sort of template right there to help you figure this out. All right, so let's go to G. And G is kind of an interesting question. G says that a teaspoon of salt, can you picture a teaspoon? A teaspoon of salt is roughly 2,325 milligrams of salt. And so if you increase your salt intake by 1 teaspoon each day, how much do we predict your blood pressure is going to increase? So I would think of it this way. We already know this fraction. We know that this much blood pressure goes along with 1 milligram. And we're interested in how much this would go up for a teaspoon. So we would like teaspoons, 1 teaspoon, to be our new denominator. We'd like to get rid of milligrams. And we know that 1 teaspoon is equivalent to 2,325 milligrams. So we're just going to multiply these two numbers together, and that's going to give us our answer. And this is kind of wild. Check this out. 0.025 times 2325. 58 points. Okay, so my advice to you, don't eat an extra teaspoon of salt, because this would be incredibly damaging to your health. All right, so let's continue. We got one more, H. And H says, well, let's think about our health. We would like to keep our systolic blood pressure at or below 120. So the question is, how low should our salt intake be in order to facilitate that? So what I'm going to do is I'm going to take this equation that we cooked up right here, and I'm going to replace systolic blood pressure with 120. So the equation looks like this. I'll just call this X this time. And now we just solved this equation. So it's a linear equation. We want to start by subtracting the constant term. So this is 91.351 is equal to 0.025x. We divide both sides by that number. I get x is equal to 3,654 milligrams of salt. So we would want to consume 3,654 milligrams of salt or less. And by the way, your daily recommended dose is considerably lower than that. But according to this equation, that's what we come up with. All right, we will leave it at that.